It becomes a binary distribution where you have more than one triad, and the number of triads is defined by n in that formula. While x is the number of successes we are trying to calculate the probability. Okay. Then we had to do some calculations on we had to calculate and interpret probabilities given the discrete, uniform, and binomial distribution functions. We know what we mean by a discrete distribution as against when the distribution is a continuous one. Okay. Then I'm sure by now we all remember the formula for binomial distribution. Yeah. And we know the definitions of each of the variables, what n stands for, what x stands for, what is p, and what is q, or 1 minus p. Then we know how to calculate the expected value of a binomial. When you have a binomial problem, and you have to calculate the expected value, n times p. We know how to calculate the variance, n times p times 1 minus p. If you have to calculate the standard deviation, then you have to look for the square root of that expression. Then we also looked at the binomial tree last week. If you are given a problem, if you choose, you can decide to go with the tree to try to solve the problem, but that's going to be a long thing. I would rather use the formula for any given problem. Do you understand? We saw how we're trying to demonstrate that the tree is equivalent to the formula last week. Okay. Then, we tried defining the difference between, distinguishing the difference between a continuous uniform distribution. We know when we say a distribution is uniform, right? What do we mean? I've forgotten. The probabilities for each of the outcomes are equal, right? Okay. And we know how to calculate probabilities given a continuous uniform distribution. Remember that one that you gave us that fantastic formula for? The one that we drew a line, then the lower bound is A, the upper bound is B, and then if you're asked to calculate the probabilities of maybe an event occurring between two numbers, which we define as x1 and x2. Remember how we calculated the probabilities of the outcomes being between those ranges when we said x2 minus x1 divided by b minus a. Remember that? Okay, I think that's where we concluded last week. So today we're supposed to move in to normal distributions properly. So the first LOS says explain the key properties of the normal distribution. I'm sure we already mentioned this last week. What are the key properties? We said a normal distribution is defined by its mean and standard deviation. Yeah. We said if it is a standard normal distribution, then the mean would be 0. And then the variance will be 1. Do you remember? And we talked about the essence of standardization, that we do that when we try to compare maybe 2 or more different distributions. Say, for example, you have distribution of the returns of a particular stock, first bank shares, and you also have distribution of returns of another stock, GT Bank shares. Now, it's possible that the mean return of first bank shares over the past couple of years is 10%. whilst that of GT Bank is 20%, for example. Both of these two distributions may have normal distributions. That means they are defined by a particular mean and variance, right? So if we're trying to make comparisons, maybe we want to see what's the probability that the mean return of First Bank would be 6% in a particular year. Because the mean is 10%, which is different from the mean of GT Bank, we may not be able to directly compare. I don't know if you're getting what I'm saying. So this is what I'm saying. You have two distributions which you have, sorry, it may not look normal, but just assume it's normal. So we said one of the characteristics of a normal distribution is that it's defined by its mean, right, and variance of returns. Now, the mean can be anything. For it to be normal, we said the mean must be equal to the median, and that median must be equal to the mode, right? So let's say for First Bank, the mean return over the historical period, maybe since inception, the mean returns every year has been 10%. Do you understand? Whilst his own standard deviation is whatever, it can be 5% or whatever. The fact that its mean is equal to its median and the median is equal to the mode, as well as the fact that its skewness. What would be the skewness of a normal distribution? Skewness is 0, right? And if its kurtosis is equal to 3, so we'll say the distribution of returns for First Bank is normal, right? Now, we can say the same thing for GT Bank if it meets all of those conditions. If its mean is equal to its median, which is equal to its mode, and if its skewness is 0 and kurtosis is 3, we would say it is normal. Now, let's say its own mean for GT is 15%, and its own standard deviation is 10%, for example, over the relevant time frame. If you now want to make comparison, maybe you want to calculate what's the probability that the return of GT Bank, what's the probability that the return would fall below 5% this year? And you want to do the same thing for First Bank. Now, it becomes difficult. You cannot compare them directly. Do we get? Why? Because their mean and their standard deviation of returns are different. Now, to help us to be able to do this comparison, that's why we standardize. Do you understand? And to standardize, there's the formula that we use to standardize, which we'll meet in the next LOS. Bottom line, what we are trying to take out of this LOS is that these characteristics must be met for a distribution to be characterized as a normal distribution. Number one, it must be defined by a mean and standard deviation or variance, which can be anything for a normal distribution. Then secondly, we all agree that the skewness must be 0. And we know that the kurtosis must be equal to 3. We can also define it in terms of excess kurtosis. If we are saying excess kurtosis for a normal distribution must be equal to 0, right? Then one other thing that we should also note is that when we have a linear combination of normally distributed random variables, the resultant distribution would also be normal. Let's say, for example, you have a portfolio that consists of GT Bank shares and First Bank shares, and you've determined that the distribution of returns of each of the shares taken individually is normal. So by extension, because you combine these two assets in a single portfolio, you expect that the distribution of returns of that portfolio would also be normal. Do we get? So if you have a linear combination of several variables, and each of those variables are normally distributed, you expect that the resultant variable, that is a combination of those variables, would also be normal.
There's like another thing you're comparing with.
So what I'm saying is, if you have a portfolio, in a portfolio, you have more than one asset. If the distribution of returns of those assets are normal, then you expect that the distribution of the returns of the portfolio would also be normal. Do you understand? If the distribution of returns of the constituent elements of the portfolio, maybe they are not normal, then you may not be able to make that assumption that the distribution of the portfolio would be normal. Do you understand? So that's one characteristics or properties of normal distribution. Okay, then lastly, we have the probabilities of outcomes further above and below the mean get smaller and smaller, but do not get to zero. Okay, for a normal distribution, we know that the distribution of outcomes is between minus infinity, right, and plus infinity, right? So the further away you move away from the mean, let's say you're trying to calculate the probability of an outcome equal to maybe minus 1000%, for example, is going to be a positive value. Do we get? Because there's no lower bound. If I gave you a distribution and I said, this is a distribution, the lower bound is 5, and maybe the upper bound is infinity. What this means is, if I ask you to calculate the probability of an outcome equals to 4, you know it is 0, because it cannot happen. Do you understand?
Yes.
However, we said for a normal distribution, there is no lower bound, in that you can have minus whatever. It can be minus 1 billion, it can be minus 10 billion, or those are possible outcomes. You can also have extreme positive values. However, if you are looking at a distribution that is bounded, maybe there's a lower limit or upper limit, the probability that you would have an outcome that is lower than this lower limit is 0. Do you understand? However, for a normal distribution, because there is no lower limit, the probability of an outcome occurring, the farther away you move from the mean, it will still be positive, even though it may become maybe 0.005 or 0.0000001. It will return a positive number. Why? Because those extreme numbers are possible. Do we get? Okay, for this particular distribution, no, this one cannot qualify as a normal distribution anymore, because there's a lower bound. For a normal distribution, the range of possible outcomes is between minus infinity and plus infinity. Do we get? What determines whether that distribution is normal is because we know that it has met all of these conditions. It has a mean that we all know and a particular variance. The mean is equal to the median and is equal to the mode. In terms of skewness, the distribution of returns has 0 skewness. Do you understand? That means it's symmetrical. Do we get? Then in terms of kurtosis, the kurtosis is equal to 3 for a normal distribution. Do we get? Now, for a normal distribution, because the range of possible outcomes is from minus infinity to plus infinity, what that just tells us is it can be anything. Do you understand? So when I tell you calculate the probability of an outcome, let's say the mean, like the case of this GT Bank, is 15%. If I say what's the probability that an outcome will be below 5%, that's this portion, right? That probability would be a positive number, but it will get smaller as we move away from the mean. So if I ask you to calculate what's the probability of an outcome below 1%, it will also be a positive number, but it will be small. Do we get?
So what should we now enter negatively? Because I thought things on.
Okay, remember last week we also said under the curve, what's the sum of, under the curve is where we have the probabilities. we said the sum of the probability is equal to 1, right? So disregard this negative that you have here, minus infinity. It's talking about the events, not the probability. Do you understand? The possible outcome. I hope that, okay. Bottom line, what we are taking away from this last point is that because of the shape of the normal curve, you find out that most of the possible outcomes are concentrated around the mean. Do you understand? If you look at all this stuff as maybe possible frequencies, so most of the possibilities are clustered around the mean. The farther away you move from the mean, the less likely that you'd have that event. Do you understand? But that lower likelihood does not mean that the possibility is 0. It means that it's a very small possibility. Do we get? Okay. So those are the properties of a normal distribution, and we have to know them. They can spin any question out of this. Can be calculation, it can be just normal words. Do you understand? I can give you a distribution, and then I would say, calculate I will tell you that the distribution is normally distributed. And I will tell you what's the probability of a particular outcome, maybe minus 5%. And then in the options, I give you A, 0%, B, minus 2%, C, 0.2%. I'll just pick this one. I don't need any calculation. Why? Because I know that a probability can never be negative. And because it's normally distributed, it cannot be 0. It has to be a positive number. The farther away I move from the mean, the smaller that probability would be, but it will never be 0. Do we get? So that's a possible question that can come out. Again, I can ask you, determine whether this particular distribution is a normal distribution, and I give you all the characteristics. Its mean is equal to 20, and that standard deviation of 5. And then I tell you the median and the mode are equal to the mean. But then I tell you the skewness has been calculated as 0.2. And then I tell you the kurtosis is 3. Is it normally distributed? No, because it has violated one of the characteristics of a normal distribution. So the next LOS says, distinguish between a univariate and multivariate distribution and explain the role of correlation in the multivariate normal distribution. So this feeds from these points that we made here. That would say the linear combination of normally distributed random variables is also normally distributed. And the easiest example to pull out is that of a portfolio. If you have a portfolio of maybe stocks and bonds or whatever, once you make the assumption that the distribution of returns of the individual constituents of the portfolio are normally distributed, and you're now trying to figure out you are trying to figure out if the portfolio in itself, if the distribution of its returns are normally distributed. So if it meets all of these conditions, like if it meets the condition that for each of the constituents, they meet all these normal distribution requirements, then we can say for sure that the particular portfolio, the distribution of returns of that portfolio, which is a multivariate distribution, because it's picking its characteristics from the characteristics of its constituents, then we can say for sure that that distribution is normal. Lorocon, cut long story short, what we are saying is a univariate distribution, even from the term uni, you are looking at just one variable. Multivariate, you are looking at multiple variables. determining the characteristics of maybe a portfolio. So for a univariate distributions, that's what we've been discussing all the while. For multivariates, we said it specifies the probabilities associated with a group of random variables, and is meaningful only when the behavior of each random variable in the group is in some way dependent upon the behaviors of others. Cut long story short, remember when we discussed variance of a portfolio, calculating the variance of a portfolio and the mean of a portfolio? Remember how we arrived at the mean? How did we arrive at it? So we looked at, to determine the mean of the portfolio, you looked at the weights of each of the constituents in the portfolio, right? I also looked at the mean of each of those constituents. The mean of the portfolio is derived as the weighted mean of each of the constituents, right? Now, the variance of the portfolio, when we're calculating it, what were the things that we looked at? From the formula, just tell me the important variables. So you took note of the weight of the constituents, right? What else?
Plus 2 multiplied by variance.
So you looked at the variance or the standard deviation of each of the constituents, right? So if they are normally distributed, you expect at the end of the day, the distribution of the portfolio would be normal. What else did you look at? Correlation. So that means the characteristics of the distribution of the multivariate portfolio takes a cue from the correlations between each of the constituents. I don't know if it's clear. If you have let's say you have a 2-asset portfolio, First Bank and GT Bank, and you're trying to determine the variance of that portfolio. Part of what you look at, you said you look at the weights of each of these constituents in that portfolio, right? So if GT Bank occupies 70%, maybe I spent 70, is a 1 million naira portfolio. 700,000 naira is invested in GT Bank, and then 300,000 is invested in First Bank. If we are trying to calculate the mean return of this portfolio, or the expected return of this portfolio, how are we going to calculate it? It will be the weight of this guy multiplied by this, right? Plus the weight 30% multiplied by the mean 10% there. When we sum that, that will tell us the mean of the portfolio, right? Now, if we're looking at the variance, like the riskiness of the portfolio as a whole, you said you are going to look at the weights of each of the constituents, right? You're also going to look at what the variance or the standard deviation of each of the portfolios, each of the constituents of the portfolio. And then one other thing that I said you will look at is the correlation of returns, right? Now, which one is better from a portfolio perspective? Do you want the assets, if the assets are strongly positively correlated, how will that impact on the variance of the portfolio? Will the portfolio be more risky or less risky? More risky. So you can see that information on the correlation between those two variables to an extent determines the characteristics of the portfolio. Do you understand? Yeah. To calculate the portfolio standard deviation, we did not only just consider 10%, which is the standard deviation of this, and 15% to determine the portfolio's standard deviation. We also looked at the correlation of returns, right? In this particular case, how many correlations did we look at? Just one. The correlation between First Bank and GT Bank. Now, imagine we have 3 assets, First Bank, GT Bank, and maybe Fidelity Bank in our portfolio. If we are trying to calculate the variance of the portfolio, how many correlations are we going to have? We're going to have correlation between First Bank and GT Bank. That's one. We're going to have between First Bank and Fidelity. That's two. And we'll have between GT and Fidelity. Three possible correlations, right? Remember, in this our in quant, we only stopped at two asset portfolio when we're trying to calculate the variance of the portfolio. But I remember that we mentioned that it can be any number. And once it's 3, for example, your expression would expand. Do you understand? You remember we discussed that. So under this reading, to determine how many number of correlations we would need to calculate, there's a formula for it, which they gave us 0.5 times n times n minus 1. It's possible now. It's possible. They can ask you that how many pairwise. So I would give you a multivariate distribution that consists of 3 assets. And I'll tell you that how many variables will be needed to define the characteristics of the multivariate distribution. For a 2-asset portfolio, how many means did you require? 2. You require the mean of First Bank and the mean of GT Bank, right? How many standard deviations did you require? 2. How many correlations? 1. If it's a 3-asset portfolio, how many means are you going to require? 3. Standard deviation? 3. Correlation? 3. So I can ask you, for a 20-asset portfolio, which of the following is true when you're trying to define a multivariate distribution? And then I give you mean, 20 means, you require 20 means, 20 standard deviation, and 500 correlations. How do you determine which of the options is correct? So that's where you use that formula. Say 0.5 times n times n minus 1 is constant. I can actually demonstrate it. It will be a long thing, but I can use 3, for example, to show you. If you have maybe First Bank, GT Bank, and Access Bank, and want to do the correlation matrix for these guys, let me say this is covariance matrix. Let me do covariance. This side, this FF is the variance of F, right? Let's say this is a standard deviation. This standard deviation times this standard deviation is the variance of F, right? So this would not account that if you are doing the correlation of this return, it will be what? 1. You are trying to compare the distribution of my returns with myself. It will be 1, right? So I won't consider this. But this one I have F, G, right? G, F, and then G. These are variances, right? This one is the same thing as this guy. You understand? So if you are looking at number of unique correlations that you need, it will be 3, 1, 2, 3, right? If I extended this table to 4, maybe this is something B. So this will be I'm coming, I'll try to explain again. So we are looking at, sorry? Maybe I can put up.
Put on the work. See the work.
Okay. How will I put that off? Okay. So if we are looking at a 4-variable whatever, how many unique correlations do we have? 1, 2, 3, 4, 5, 6. So what this formula is just doing is, instead of drawing all these long table, you just say, okay, for a 4-variable now, it will be 0.5 times 4 times 4 minus 1, 3. 4 times 3 is 12. This formula is for determining the number of unique correlations that you would need when you're trying to define the properties of a multivariate distribution. You understand? No. Okay, what I was trying to do here is to see how, like, the wisdom behind this formula. This one. So which one? This one.
No.
Where we are trying to arrive at is, what are the characteristics that we need when we're trying to define a multivariate distribution? We said number one, we'll look at the number of variables that make up that multivariate distribution. And I was trying to use a portfolio that consists of First Bank and GT Bank as an example. If you're trying to define the characteristics of the distribution of the portfolio that consists of these two assets, you have two means, like the mean of First Bank returns and that of GT Bank returns. That's one, like two different variables. You also have the standard deviation of returns of First Bank and the standard deviation of returns of GT Bank as another variable, set of variables that you need to define the characteristics of the population. Now, we also said, aside mean and standard deviation, you also need the number of pairwise correlations between the assets that make up the portfolio. Remember, if you were trying to calculate the mean of the portfolio, it would have just been the weighted mean. To calculate that, what you need is the mean of A and the mean of B with their respective weights. If you wanted to calculate the variance of the portfolio, you would need the variance of, or the standard deviation of this portfolio, of this asset. You need the standard deviation of that asset. You need their weights, and you also need the correlation. Do you understand? For a 2-asset portfolio, you have just one correlation, which is the correlation of this and that. If it is 3-asset portfolio, you have how many possible correlations to look at? Correlation of this and this, correlation of this and that, and correlation of this and this. 3 unique correlations to grapple with. How about if it is 20? You use this formula to determine the number of pairwise correlations that you would need. So that would just be 0.5 times 20 times 19. So that will tell you the number of correlations that you need. Yes. Is it clear? So yeah, I was just trying to show it in a table format, but you don't need this. Okay. Okay, sorry. So they said, using asset returns as our random variables, the multivariate normal distribution for the returns of n assets can be completely defined by the following sets of parameters. N means of the n series of returns. That one is clear. Like how many assets are in the portfolio, for example. If you have 20 assets, you need 20 means, 20 different means, right? N variances as well. If you have 20 assets, you need 20 variances. And then in terms of the number of pairwise correlations that you need, is defined by that formula, 0.5 times n minus 1. how can they ask questions? I already give an example of how the question can come. Okay, so the next LOS says, determine the probability that a normally distributed random variable lies inside a given interval. Did we already discuss confidence interval? No. Okay. So what's the confidence interval?
Yeah, the range of value of expected outcome.
Okay. Yeah, they said a confidence interval is a range of values around the expected outcome within which we can expect the actual outcome to be some specified percentage of it. Long grammar. So you have First Bank shares. You figured out that the returns are normally distributed. Do you understand? And you already know the mean. The mean is 10%, right? You already know what the standard deviation of returns are. Let's say the standard deviation as calculated is 2%. Now we said because of the shape of this curve, right, you expect that if you are looking at one standard deviation away from the mean, what would one standard deviation away from the mean be? 10% plus 1 times 2. If the mean is x bar, one standard deviation away from the mean is like I'm adding one standard deviation to the mean, right? So that's like I'm adding plus 1 times standard deviation, right? So in this particular case, one standard deviation away from the mean would be 12%, right? In this direction. In the other direction, I would minus 2%, so that would be 8%, right? Remember, we also said if you shade this area, what this is representing is what? The probability that your outcome will be between 8 and 12%. Do you understand? So if we say our confidence interval of x bar, what's our confidence, our level of confidence that our outcome would be between 8 and 12%? It will be the probability that is defined by this range. Do we get?
Yeah.
So if we calculate that probability, and the probability is maybe 0.9, for example, we can now say that we are 90% sure that at any given time, when you randomly pick maybe a particular year, that the return would fall between 8 and 12%. Do we get?
Since all represents one, right?
Since
We go to the numbers.
in this our example, we are looking at one standard deviation away from the mean in both directions. So if, when we check the table, our z table, our probability is calculated as 0.9, what we are saying is that we are 90% sure that if you pick any random variable, it will be between 8 and 12. Or alternatively, it will be between one standard deviation away from the mean.
How do we arrive at this?
How do I arrive at 0.9? We would meet it. But just know the interpretation now. So if you say 2 standard deviation away from the mean, that would be 10% plus or minus what's our 2 times our standard deviation, which is 2, right? So that would be 10 plus 4, 14, and what? 6. So if I ask you to tell me what the confidence, like what's your confidence level that your outcome will be between 6 and 14, it's after you calculate the probability of this shaded area. That you'll be able to tell me if, for example, that's now 0.91, for example. So you say you are 91% confident that your outcome will fall between 6% and 14%. Do we get? How we get the percentages is because we know that the total area under the curve is equal to 1, right? Which is the same thing as 100%. So that means at no point would you calculate, or would you be asked to calculate a confidence interval that is above 100%. Do we get? Yes. So let's move down. But hope we get this simple example. Okay, so they said confidence interval is a range of values around the expected outcome within which we expect the actual outcome to be some specified percentage of the time. Now, a 95% confidence interval, they said, is the range that we expect the random variable to be in 95% of the time. So if I ask you to calculate the confidence interval, 95% confidence interval, that means I'm telling you, tell me the range of outcomes within which you are 95% sure that once you pick a random variable, it will fall within that number. Do you understand? Now, how many standard deviations away from the mean would give us 95% confidence interval? Is a particular number. You understand? For this one standard deviation, there's a number. And we can check that number from the Z table. For 2 standard deviation, there's a number. We can check it from our Z table. Do you understand? Okay. Now, there are some numbers that you must cram. Yeah. You must cram the 90%, the Z value. Now, what I mean by the Z value is this value that you have before the standard deviation. So this one, for example, is this Z value for a particular percentage level of confidence. Do you get? No. In normal distribution, remember we talked about standardizing our normal distribution, right? And then after we have standardized our normal distribution, we said our mean would now be 0, right? And our variance or standard deviation would be 1, right? Now, we also said that the total area under this normal curve is equal to 1, right? Which is our probability, right? At the last class, when we're doing the CDF, whatever, cumulative distribution function, we said if you are asked to calculate, say, what's the probability, what's the f of, let's say this is -1, f of -1, what you're calculating is the same thing as probability of x less than or equal to -1. We remember, Abby? And that's represented by this shaded area. We remember? Good. So if you're now asked to calculate, now this -1 that I put here is like the Z value. So if I wanted to check the table to see what probability is represented by this portion that I've shaded, I will check -1 on my Z table. Do we get?
Yes.
Do you all have the Z table?
Yeah.
You find at the end of the curriculum. Even it should be in Shredder as well. Okay. Check what -1 is. Okay, the first question I should ask, do you know how to check the... Okay. Okay.
I think those things to check.
Let me see if I can project the Z table. Okay. So this is the Z table. So I was saying, if you are asked to, if you are given an example like the one I just created there, where this is a standard normal distribution. Okay, maybe I should start. For you to use this table, you must standardize your normal distribution. And there's a formula for standardization. You understand? Which is the formula that we use to determine what our Z would be. So if I gave you a question, because I've already standardized this -1 that I have here is like my Z figure. Why? Because we said f of -1 is the same thing as probability of x less than or equal to -1. And our Z table is defined as p z less than or equal to x. In this particular instance, my x is -1, right? So my Z is -1. How do you now check the table? Here you have X or Z. Is it clear? What you have here is X or Z. So here you have 0, -0.1, minus whatever. In this our example, it is -1. So you look for -1. Here, this is -1, right? If it is -1.2, this is -1. Here you have 0, 0.01, 0.02. So you trace this line to this 0.02. So this number that you have here would be the probability that is represented by this shaded area. Is it clear? The probability is not the minus. The Z is the minus. It's the one that has -1 point whatever. Inside this table, what you have inside this table is the probability.
But you said 1.2. It's 1.2.
Okay, sorry. It was 1.02 that I wanted to. Sorry. 1.02. You can even see if this is -1 and this is just the second figure, that's 0.12. If it's -1.2, it should be this under 0. Do you get? So it's easy to check. Now it's possible that if I ask you that what's the probability, no, don't worry, don't let me complicate things yet.
Oh, again.
But we know how to check. We know how to check our Z value, right? Okay.
I understand how to use it. I don't know why I'm using it.
You don't know why you're using it. Good. Why you're using it is you're trying to calculate probability. You understand? The probability that is defined by this Z distribution is the probability of X less than or equal to a particular Z value.
It's 5%. That's big. I didn't use it.
They can be related. Let me explain how they are related. I can check the Z value for 95%. Remember I said inside this table is where you have the probabilities, right? And for a normal distribution, we know the difference between one tail and two tail, right? This is a two-tailed distribution table. So if I say find 5%, 95% confidence level if I say find 95% confidence level, remember we said the confidence level is how many standard deviation away from the mean, right? So if it's 95%, if this portion that I put this dot dot is 95%, and this distribution is symmetrical, so what would this tail be? 2.5, because it will be half of what is left. Do you get? If we say this distribution is symmetrical, that means this half is equal to this half, right? And we said for confidence interval, what we're trying to calculate is what is the probability that our outcome will be between x, maybe x, z standard deviations from the mean. Let me use z standard deviation from the mean. I said if we are looking at 2 standard deviations from the mean, for example, our z will be 2, right? So 2 standard deviation will look on this table for 2.0. This one is minus, right? We also have the positive table. Let me see if it's in.
How do you know my question is, you have seen that these are two fields.
Yeah.
How do you use it to be because sometimes it's really fine to work.
How do we know that it's two-tailed? Now, you get the gist on the confidence interval, Abby. So if I said, what's our 90% confidence interval? What I'm simply saying is, what is the range of values within which we'll be 90% sure that a variable would be? Am I speaking? So if this is our mean, our standardized mean of 0, and then we're trying to say, what is the range within which we can be 90% sure?
Okay, my question. I understand that it's 5%.
How is it two-tailed, Abby? That's the question.
Not that table.
Yeah.
That table is two, not one field. Because they didn't write it.
A normal distribution, because it's symmetrical, and because the way the table is defined is, if you say calculate z of -1, what you are simply saying is from -1, what's the probability that x will be -1 or less? Do you understand? Which is represented by this portion. Clear? Now, we also know that this distribution is symmetrical, right? Because it's normal distribution. So this shaded portion would be the same as this other part. Do you understand? And we know that our confidence level is, we are looking at what's the probability that an outcome will be between this guy and this guy. Do you get? So this is 90%. Our z that we are checking should it be 10% or 5%? It should be 5%, because we know that it's symmetrical. 5%, half of what we are trying to check will be here, and the other half will be on the other side. What was your question?
My question is not about that. I would actually the table that is the table.
How do you know it's two-tailed?
Then I come at more, then how then I come at this table is two-tailed. They don't write it again. And enough.
For a normal distribution problem, it has to be two tails. If it is t-distribution, now you now have to define, am I solving a two-tailed problem or a one-tailed problem? Do you get? Okay, back to how we can use this table to find our z value.
Still, if you go to providers, there's 95%.
If they are going to ask you a question that would require the table, they may provide it to you, or they will give you the z value.
But I think most times,
But if they're asking for 90%, 95%, and 99%, they will not give you, because they expect you to cram it.
yeah.
Do you understand?
Yeah, because this question is so.
90, 95, 99, you must cram it.
Yeah.
Yes, you must cram the z value.
99,
Will be 0.05.
one variable.
Yeah,
0.5. So it's 0.5.
percent. 0.005 rather. What is inside there is the probability. Do you understand? So if I say what's 90% probability, like your confidence interval is 90%, to check this table, you would look for where you have 0.90. But if you do for 0.90, you will be wrong because it's a two-tail distribution. Two-tail meaning that it will be 0.95 that I'm looking for in this table. Maybe I should not confuse you then.
Let's just get to the part.
When you started, you said you would do 100 minus 90.
That's 10 now.
No, that's the divide.
Yeah. Mm-hmm.
That's 5.
Yeah.
Now again, you're saying it's the 90 I'm looking for. Which one am I?
So 5%, that's 5% that you look for, right? 0.05, right? But to look for the probability here, you can look for 0.05 in this one because our z values are negative here. If it is the positive one, you would have the range from 0.5 to 0.9.
What you're saying that we look for.
In this particular one,
What am I looking for in 0.05 and 90%?
this is our probability, right? So you look for, remember inside this table, what you have here is the probability. What you have outside is the z value. So if you're trying to see how many standard deviations from the mean is represented by this my z value, like if you're trying to find, in our example, I did one standard deviation from the mean. If I was trying to look for what's the percentage or the probability that our outcome will be one standard deviation from the mean, I would have just looked for, one, where's one here? This is 1. We have this table is a minus table. So I'll look for -1, which is this. Do you understand? And I'll now subtract this from 1. So that will be 0.8413.
Why are we subtracting from 1?
Because the table is a negative. If the table was positive, you would have just picked the figure. I'm sure if you have the positive table, it will be 0.8413. You have the positive table, Ari? I think I've confused you people. So let me restart. Let me restart. Ask.
I think it goes very, very far, right?
In this, no, we've not gone very far. Okay. So let me go back to where we're coming from, so that I'll put the pieces together.
Do you make out time for some questions?
Yes. Okay. Maybe I should even go straight to this table. Now, in this table, what we have here for one standard deviation from the mean, we said is 68%, right? Now, when we check that table, what was our z value? Okay, this one is negative. Do you have the positive one? Oh. So for one standard deviation from the mean, we're trying to see what would our z value be, right? So one standard deviation, that's 0 points. I'm coming -1.6 68%. So 68%, 1 minus 68% is what? 1 minus 0.68, 0.32. So that should be what we have in this range, right? So in between here, we said the area should be 68%, right? So at this tail, it should be half of 0.32, right? So here we should have 16% in this tail, and then 16% in this tail. Now, if you want to check the probability for 0.16, okay, yeah, I have the positive table. So because there is no 0.16 in this probability, I'll do 1 minus 0.16. That should be 0.9, 0.84.
There's no one.
Huh?
So there's no one. Why am I taking it?
The tables, there are some things that you must bear in mind. When you're solving a standard normal distribution problem, you can have two tables for your z values. If you have the negative values for your z, what that table is telling you is that, you know, this is our mean. To this end, you have the negative distributions. Here you have the positive distributions. Now, -1 is this. This is +1. So if you check your positive table for +1, what you are checking is the probability that z will be 1 or less, which is this entire portion up to the end. Do you get? But what you're actually looking for is this portion. Because this side is symmetrical to this side, if you know the area of this one, you can deduct 1 from it to get this one. So that's where the confusion on the table comes. If the table that you have is a negative table and they ask you to calculate z +1, because the table that you are checking has only -1, the figure you will check will give you the probability of this portion. But what you are looking for is probability of this one. Do you understand? So how do you get the probability that your this thing will be in this region? It will be 1 minus this one. So that's the small, if you are not mindful of what the definition of what you are calculating is, you may have some problems in checking the table. Number one, when you're checking your z table, if you're checking for z is equal to 1.5, you are saying what's the probability that from my z table that my distribution will be 1.5 standard deviations from the mean, and that would be a positive value all the way down like this. Do you understand? So what you have checked is probability of z less than or equal to x. If what you actually need is what's the probability that it is greater than that 1.5, you will do 1 minus whatever you checked from the table to give you this portion, which is what you are interested in. Is it clear?
Yeah.
I've confused us. You know, let's get to how we calculate our z value, and then we'll now start checking the table. Maybe that would clear some of the confusion. But what I want you to know from this point is, ask.
The positive, if you have a positive table, I'm looking for -1. So F1 is going to be from this region downwards, right?
If you have a negative table, positive table, and you're looking for F minus 1, what the table would give you will be F1, which is from this point all the way down. But what you're looking for is F minus 1, this portion. Now, because this is a symmetrical distribution, you know that this portion for F minus 1 is the same thing as plus 1 all the way down. Do you understand? So you can check for the F minus 1, which will give you all this portion, then subtract 1 from it. That will give you this, which is synonymous to this other portion. Do we get? When you check the table, we don't get. When you check your Z table, after you've calculated your Z, maybe your Z is 1.92, for example, and you've checked your Z table, you would get the probability. Let's say your Z is 1.92, right? Now, remember we said, once you are checking your table, what you are checking for is from that Z figure, 1.92, all the way down this way.
They are positive or negative.
Either,
Positive or negative.
what do you mean by either positive or negative?
Say 1.92, this is negative.
Okay, yeah, what I've calculated is a positive 1.92, but the table I have is negative table. So what I will just check is, if this is 1.92, whatever the area is from 1.92 upwards will be the same area from minus 1.92 downwards. Do we get?
So I think we're using a two-tailed table to answer one question. Does that P into bracket Z less than equals to X is in one tail, right?
Px less than or equal to Z.
That is in one tail.
Yes.
So we're using a two-tailed table to answer one tailed question.
It's two-tailed. You know why? What we are looking at is, if you are looking for Z less than or equal to 1.92, it is this portion, from this portion downwards. But because the table you have may not be the negative table, it's the positive table. So you're trying to use what you have to find what you don't have. So because I know that the laws of symmetry from minus 1.92 all the way to the end of the tail is the same thing as from plus 1.92 all the way to the end. Now, if I check plus 1.92, what the table is giving me is this value, like X less than or equal to whatever I'm checking. So if I check for 1.92, what I would have is the probability from that 1.92 all the way down. But what I actually want is this one, this tail.
So if it's symmetrical, it's saying you want to have
Shouldn't it be?
same answer on both sides instead of X minus 1.
If I have the minus table, the Z minus table, I'll just check minus 1.92 straight.
So left and right side can be different.
No, it's the same. You don't get. What I'm saying is, if you find yourself in a situation where you only have a negative table, you don't have the positive counterpart, and you have to, if I'm supposed to calculate for minus 1.92, it is straight, it is easy for me because I have the negative table. I'll just check minus 1.9 under 2. So the probability will be 0.0274. The probability of outcomes being less than or equal to minus 1.92. However, what would happen in a situation where I have a positive table? So I can't even see minus 1.92. So I'll now say, okay, because I know that minus 1.92 down is the same thing as plus 1.92 up. So let me check plus 1.92 for the Z-score. After I check the plus, you're not fine. Are you serious?
Fine.
Are you serious?
We just wanted to know whether the probabilities, so you're saying the probabilities are the same, but the Z-scores are different.
Yes.
That's all I mean.
The probability on each of the tails will be the same. Yeah.
Z-scores are different.
Yeah. Are you sure?
Yeah, that's it. Fine.
Don't worry.
The negative table that we have, but we were looking for the positive or minus 1, and we do the same thing if it's the opposite.
Yeah.
So I'm fine.
Okay. So how do we even calculate this our z? Maybe we should get there. When we get there, and we'll come back to this table, I will now re-explain the table. Okay. Okay, these are the numbers that I said we must memorize, whether you like it or not. This z value, for 90% confidence level, it will be 1.65 standard deviation from the mean.
Sorry. Well, this 90% confidence level, I think it's like a very good question. I don't know, because I've seen some questions that they actually use something 3 decimal places. This one is already
If they don't give you in the exam, you use 1.65.
2 decimal places.
Yes. If they give you, because it's possible that they will specify in the exam that z is equal to 2.141, kinikon, use what they give you. If they don't specify, they expect you to at least know these numbers.
Was not given, and the solution they used 3 decimal places.
Oh.
Yes, it wasn't given, and the solution they used 3 decimal places.
2 decimal places, you are fine. You are fine. So you must know for 90% confidence interval, your z-score is 1.65. For 95%, it is 1.96. And for 99%, it's 2.58. If you don't know any other thing, you just keep it in one side of your head. 1.65 for 90% confidence level, 1.96. That one is the easiest. 95%, okay, 1.96. I just know it's close. And once I remember 1.96, I know the next one is 2.58. And the one above is 1.65. 90 is 1.65. 95% is 1.96. 99% is 2.58. You must know it. Do we get? So if I have to calculate the 90% confidence interval for whatever, and they've given you the mean, what you just need to do is that mean plus or minus, if it's 90%, 1.65 times the standard deviation. You add it to get the upper limit, you subtract it to get the lower limit. So you can now say, okay, like
This whole
Z table.
so this is the question.
No, this is not only the point. It's part of it. So we said 90% confidence interval for X is X bar plus or minus 1.65 times standard deviation. It's like you're trying to get a range of values. If your X is 20% and your standard deviation is 5%, if you have to calculate the 90% confidence level, the Z value that you should use will be 1.65. So what you just do is X bar, which is 20% plus for the upper limit, plus 1.65 times the standard deviation, 5%. Whatever I get will be the upper limit. Then I'll do 20% minus 1.65 times standard deviation to get the lower limit. By the time I calculate it, let's say this is 15, and maybe this is 22. So I'll now say I'm 90% confident that when I pick a random variable, they will fall between this range, 15 and 22. Do you understand? If they say, okay, what's the 95% confidence interval? It's the same formula, but I'll replace this 1.65 with 1.96. Then I'll calculate the upper limit, the lower limit of my range. And then I'll now interpret it to mean that I am 95% confident that at any given point, if I pick a random variable for X, it will fall in that range. Do you understand? The same thing for 99%. Is it clear?
Yeah.
Okay.
Sorry, I'm trying to Yeah, I think I was mixing it up with this Chev's inequality upper and lower limit. So it was getting me confused. I think that one is x over plus or minus k x bar, right?
Mhm.
To find upper and lower limits.
Yeah.
But this one it replaces this x bar with standard deviation. That's like different.
No, for Chebyshev is what? X bar plus or minus
K x.
is standard deviation. No,
Why not
it's standard deviation. It's standard deviation as well. Okay. So the next LOS is define the standard normal distribution, explain how to standardize a random variable, and calculate and interpret probabilities using the standard normal distribution. So the formula that we need to know to standardize any distribution, any normal distribution is this. Remember, to check our table, we need to know what our z is. So to calculate that z, it will be x minus the mean divided by the standard deviation. This formula, you must know it. How do you calculate z? X minus mean over standard deviation. This will be the mean of the distribution, and this will be the standard deviation of the distribution. Is it clear? Huh? Yeah. Population, your distribution. Okay. So what is the standard normal distribution? We already said it. That is a normal distribution that has been standardized so that the mean is 0 and the standard deviation is 1. And usually they represent it with this notation, where this is mean and this is standard deviation. Again, I said, for us to be able to use the tables to determine probabilities, we need to know our z, right? How do we calculate the z? We use this formula. Sorry? The x. So if, for example, I gave you a question, like, let me go back to my first bank example that I was using. I tell you that the mean is 15%, right? And standard deviation is 10%. So if I now ask you, calculate the probability that the return in a particular year or in any particular year would be 10%. This 10%, you know what I'm asking you to calculate is probability from this 10% downward, right? So this 10% will be your x. Do you get? Our mean will be the 15. And our standard deviation will be 10. So we use this z formula to say z is equal to 10 minus 15 over standard deviation of 10, right? So this will give us minus 0.5. So I'll go to the table to check for minus 0.5. Do you understand? Once I check for minus 0.5, whatever figure I get as my probability is defining this part. Now, if the question was calculate the probability, or what is the probability that in any given year the returns will be greater than 10%. So you would have checked your z table to get probability, but the probability you would get is for this tail. So to now get greater than, it will be 1 minus. Do you get? Yeah. So you must pay. So you must pay attention to what exactly is the question asking. You must know what you are checking in your z table. At any point in time, after you've calculated your z, what you are checking is from that point, that z point, down to the left tail. So it's now for you to determine what is the question asking me. Are they asking for the probability of this left tail, or are they asking for the rest of the tail? If they're asking for the rest, like greater than 10%, it will be 1 minus whatever I checked on my z table. Do you understand?
Yes.
Now, in this particular, okay. Okay. You don't understand? Okay. This is our example. I said, let me use this our example of First Bank shares to explain how to check our normal distribution table. We said the formula is x minus mean over standard deviation.
X.
We know mean. I'll come to x. The mean is what was given to us, 15% as the mean of the whatever. Standard deviation has been given. So if I now ask you a question that calculate the probability that in any given year, the returns will be less than or equal to 10%. From this our normal distribution, I know that for sure that 10% is to the left of 15%, right? So let's say 10% is this point. So what the question is asking me for is probability that the outcome in any given year will be 10% or less, right? Which is this portion I've shaded. It's clear, Abi? Now, let's go to the Z table. For us to know what exactly are we going to be checking in the Z table, we use this formula. Our X is that 10% that we're trying to see what's probability of X and below. Sorry, 10% and below. So that will be 10X minus the mean, 15, divided by the standard deviation, 10%. So we'll calculate that our Z as minus 0.5, right? So we'll go to our Z table. Now, one of two things would happen to you when you're trying to check your Z table. It's either you are fortunate enough to have a Z table that is negative. Remember the one that I displayed, add minus whatever. This one is a minus table, right? So I can check minus 0.5 straight up, right? How do I check that? Minus 0.5, this is it. Minus 0.50. So the probability is 0.3085. So I'll say the probability that in any given year, our returns will be at least 10% is equal to 0.3085. It's straightforward because I have a negative Z table. It is possible also that the table that you have is a positive table, right? Now, remember we said when you're checking your Z table, if you check, because you don't have minus 0.5, you'll be forced to check plus 0.5 in your Z table, right? Now, to calculate your plus 0.5, it will be somewhere here. When you check the table, the probability you will check would represent from this point all the way down. Do you get? So that will probably be, I'm sure it will be 0.6, is it 6815? Who has a positive table? Okay. 0.5. Okay, 6915, sorry. That's what we have here. You can see. So what we have checked on the table is probability of this point all the way down. But what we actually need is the probability on this tail, right? But we know, because we know that a normal distribution is symmetrical, we know that the probability on this tail is the same thing as probability on this tail. To calculate the probability on this tail, it will be 1 minus what we checked on the table for this whole part, right? Which is the 0.6915. So by the time I do 1 minus this, I will get this part as 0.3085. What the question has asked for is this point down. And this point down is the same thing as this point up. So I will just say my answer is this.
That's if I have to positive.
It won't be minus because probability can never be minus. Do we get?
So you check for the positive.
You check for the positive when you have a positive table. But then when you find the answer, you minus 1 from that answer. So if your question is if we calculated a positive z value and we have a negative table.
Well, if you have the negative,
If we have a negative table, so we just check minus 0.5 straight off, which is this. And we know that from minus 0.5, it will be from this point down, and that's exactly what we are looking for. So I don't need to do any 1 minus.
all right.
Is it clear? Bottom line is know exactly what you are looking for. And know that when you are checking your z table, you are checking for that z value all the way to the left tail. So if you know what you are looking for and you know what you have checked, you will know how to find what you are looking for.
Sorry, question. The number of standard deviations from the mean was can there a negative in the value of this standard? It's always positive, right?
This standard deviation that you are given,
The number of standard deviations from the mean.
that's our z.
Yes.
It can be negative. Can be negative. So is it clear?
I'm quite amazing. Knowing where to minus 1 minus.
And that's what I'm trying to explain. Once you get it, you'll be sorted. Any normal distribution question you'll be able to solve. Number one thing is calculate your z, right? After you've calculated your z, check the table that you have. If you've calculated a negative z and you have a negative table, your work is less. Just check that negative figure once and for all, and you move on with your life. When you check the negative, like this minus 0.5, if I check it on this our negative table, I have 0.3085. This 0.3085 is telling me the probability of the distribution from this point downwards, right? Now, it's now for me to determine what did the question ask me for. Did they ask me what's the probability of returns being 10% and below? If that's the question, that's what is represented by this shaded area. So I'm fine. But the question is, calculate the probability that our mean return would be greater than 10%. Even though I had a negative table and I've checked straight up what my z is, what I've checked is for this shaded portion. But what I've been asked in the question is probability that it will be greater than 10%. So what I will just need to do is 1 minus the shaded portion. Is it clear?
So for distribution, mean is always 0.
For standard normal distribution, yes.
So, what you're saying now is you can only calculate for the other ones if you're asked that it's probably take that.
Correct.
And then you now calculate.
Yeah.
But if the question is just saying less than, like less than 10%.
Yeah. Yeah. But if I'm to set question for you, it is that greater than that.
Yeah.
For this tail, you said something last time about how we're going to define things now. You said the level of confidence once in the meeting and real thing is the ones by set. Like 5 and 5. So that's 0.5.
Yeah.
And you said something about reading it on the paper. It's 0.9.
If you want to figure out the z value, okay,
So you said value, yes, yes.
z value.
Because I didn't get it.
Hope it won't get confusing for you. Okay, so let me just tell you since you've asked, so that I don't confuse the rest of the class. You want to listen? So you've been asked, if you're asked to calculate 95% confidence level, it has to be some z standard deviation from the mean. You don't know, is it 1 standard deviation, is it 2, is it 3, is it 4, is it 5? You don't know. You want to figure out how many standard deviation from the mean. The confidence level is 95%. So that means you have 5% left. And that 5% is in the 2 tails. So to find how much is on a single tail, that will be half, because they are symmetrical. So that means you expect that 2.5% will be on this tail and 2.5% will be on this other tail, right? So if I have this table, is either I look for, thank God for this one is clear, I can look for 2.5, 0.025 inside there and I'll figure out what the Z is. So let's look for 0.025.
0.250, right?
We may not be able to find 0.0250. So yeah, no, you are trying to estimate your Z. It doesn't have to be perfect. So this will, our Z will be minus 0.67.
Yes.
So that means
So that will tell you the number of this, like the dispersion from the mean. I'm not sure they asked that in level 1.
How would you get that? Like, find it.
If I don't provide the table for you,
Still, it's not provided during the exam. How would you check it? Like, what would you think? Okay.
it's either they give you the table or they give you the Z. Do you understand? They cannot. Are you a magician? That they don't expect you to cram. Now, if they want to ask you a question and they don't want to give you a table, they will restrict it to 90%, 95, and 99. And you already know the Z value. For 90%, you know it's 1.65. For 95, 1.96. For 99%, 2.5. As simple as this thing looks, I can form questions anyhow. For example, I can ask you, okay, I want to create a question and I want you to tell me the answer. Standard normal distribution. Yes.
I guess I'm learning to.
Okay. You have a particular bond in your portfolio, and you've confirmed that the distribution of returns are normal with a mean of 25% and standard deviation of 22%. The question is, what is the probability that in a given year, the returns will be between 15% and 25%? So let's say this is a standard normal distribution here. We know how to standardize our distribution by now, right? You use this formula, Z is equal to X minus mean over standard deviation, right? If we were to standardize these points all the way down, the mean will be 0, right? And that's if you assume that x is 25. X minus mean, 25 minus 25 will be 0. Divided by the standard deviation will give you 0 here. I'm just saying, for our standard normal distribution, we know our mean is always 0. And how we know that is, our x can be anything. So if we assume that our x is the mean, 25, and we're trying to calculate the z for this point, it will be 25 minus the mean, which is 25, divided by standard deviation, we get z of 0. Now the question is, we have 15%. I know 15% will be somewhere to the left. So let's take this point to be the 15%. If I want to calculate the z value of that 15%, my x will be 15. So z will be 15 minus 25 over 22. What is that? 2 points. Minus 0.45. Okay. I've escorted you to the point where you will not be scared again.
Okay, now we should.
Okay, one other thing. Let's see what we are trying to calculate. All right. So what we are trying to calculate, say find the probability that in a given year, returns will be between 15 and 25. So what you're looking for is the probability of between 15 and 25. That's this portion.
That will be 0.5 minus.
That's what we are trying to calculate, Abi. Oh yeah.
In total, that is 0.5 minus 0.5.
You finished.
Sorry.
Confirmed. So how did you solve it? Come and help us.
0.5 minus 0.2.
Okay, what did you check? Which table did you use?
No, this is okay. Tell me. Said our thing is 0. Minus 0.45.
Yeah, that's
0.45. So 1 minus this. Minus this. So 1 minus. Can you help me track? The reason why I'm minus that is because we're going this way. So can you help me? That's that is.
I don't know what you calculate.
So the other one, this one will give us 0 because it's our mean. Blah 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 0. So 0, even if it's going to go down this way, it's still going to be 0.5.
Yeah.
So 0.5 minus what we got, 4.7 something.
Is it clear? It's clear, Abi. Okay, this is what she's saying. We can check our z value for minus 0.45. Abi, when we check it, what would the probability that we would have will be probability of this point to this point, right? But that's not what we are looking for. What we are looking for is between this point and this point. So the way to go about it is we can get the probability of this point, right? And subtract the probability of this point. So that we'll be left with this region A, right? So what's the probability of z equals 0? 0.5. That represents all of these points all the way down. And it's even logical. A standard normal distribution, from the mean, you expect that the mean will divide it into 2 equal halves, right? Okay, so we have 0.5. Now the other work we need to do is check for minus 0.45 in our table. What was that? Minus 0.45, 0.3264. Do we need to make any adjustment to this?
Yes.
Okay, what adjustments?
why? I don't see.
Okay, what's the definition of this 0.3264? This probability, right? So to get this portion I've labeled A, it's just 0.5 minus that probability. Do you get? So what's the answer? That will be 0.5 minus 0.3264.
But you still get the same answer if you do so.
So what did she do? What did you do? You got,
So that they will take it.
so what you did was after you got 0.3 whatever, you minus 1 from it. So that gave you this entire portion, right? And then you now subtracted 0.5, which is like all this portion. But because this entire portion is symmetrical to this entire portion, that's why you got the right answer.
So
Do you get?
so that
We went the long way.
If it's symmetrical, you always be right on.
Yeah.
Because mean equals to mean equals to 1. So sorry, ma'am. Thank you.
You were only lucky because, let me tell you why you were lucky. You were lucky because we used the mean. If I had given you maybe between 15 and 27, it's no longer be symmetrical and you would have been wrong. You get?
I'm thinking.
Sorry, I did something else to get C.
Okay.
But I don't know if
What did you do?
I did X plus this to get my lower limit. That's X bar C standard. Sorry, X bar minus Z standard deviation to get my lower limit. So X is 25 minus. It's what I'm looking for, 22. My lower limit is minus 15. I just brought it to the other side. I still got 0.45. So it's going to be one.
Because I'm reading this time.
Yeah, it's logical. What you've done is logical.
Honestly, so
What she did was, okay, can you explain to us?
So I said since
Okay, what she did, you know this mean plus or minus Z standard deviation, right? So because she already knows the mean, Abby, and she
I know the standard.
knows the standard deviation, she knows the standard deviation, and she knows the lower limit. What's the lower limit?
15, I'm going to the question. 15, returns will be between 15 and 25.
Okay, she made this a limit. She now calculated what Z would be that would, at this point, it's logical. What she did, you know, if we were trying to get this 15%, assuming that we knew what the Z value was, we would have gotten 15. So she did the reverse to solve for Z. Yeah, maybe that's even is ingenious. You can use this in a situation where your table is lost. Yeah, but is it clear?
Yeah.
Let me create another question from this same example.
Find out the 0.5 with this 0.5.
Yeah,
So that's we call it different.
because the Z value at this point is 0. You understand? So we check the Z to get the probability from this point all the way down. We check this other Z to get the probability from this point all the way down, and we subtracted.
0.5.
Yes, it's 0.5. We saw it on the table. That's it. Z of 0, 0.5. Is it clear?
Yeah.
Now let's try to solve another question. What if he has to calculate the probability that in a given year, so returns will be between 15 and 27%. I know it's straightforward. Use your normal approach.
Where's my approach?
So what we'll be looking for is between 15 and 27. 27 will be somewhere here, right? So if I trace these points down, I'll be able to determine what my Z would be at this point, right? My Z will be 27 minus mean divided by standard deviation. So that'll be 27 minus 25 divided by 22.
0.0919.
0.0909. So you have to calculate this probability that returns will be between this range. Eh?
What is the table?
My table.
I have what's the number? No, I'm trying to say.
So what we are going to look for the probability when z is minus 0.45, Abi. And that when we get it, it will tell us the probability that is represented by this shaded area. We're also going to check the probability when z is 0.0909. When we check it on our table, it will tell us the probability from this point all the way down. So to get the region that we're trying to calculate the probability for, it will be this probability minus this probability, right? How do we, okay. Remember I said, once find probability that in a given year, returns will be between 15 and 27. So this 0.09 is 27 as our x minus the mean divided by standard deviation. Yeah, please, let's use this table. Eh? Do you have to draw it? I'll draw it. Just so that I know exactly what I'm looking for. Yeah, answer. 0 points. Is that the probability for this z? Or the answer, final answer? Talk now.
Wait, are we going to say 0.09 on the side?
Yeah.
Yes.
What is the negative?
This is the negative table, Abi.
Yeah.
So what do we do? So we checked 0.09. 0.09. And we subtract 1 from it. Okay. So what is this? 0.5359. Why did we subtract 1? Now, what we checked on the table, remember it's a negative table. So what we actually checked is z for minus 0.09. This is what we checked.
Because they don't put minus 5 at the 0.
Okay.
Should we change the positive table we have? Let's take this table.
Ah, it's true.
Well, we should find the person who can tell us.
We have to let's just confirm if it's the same.
I'm coming, I'll check. 0.4641. Yeah, correct. Yeah, correct, I think. 0.09. No,
So it's negative.
it's negative. It's negative. Why is? No, this table is for negative. How did I know? Because this is 0.09. I know that, and that's greater than 1. Sorry, it's greater than 0. So I know that the answer must be greater than 0.5.
Okay.
You get?
Yes.
We have to be greater than 0.5.
It's already to this side. Yeah.
They try 0.0. That's 0.
But if you're checking this table here, it's not a possible quick.
What's the answer?
Okay, this is a positive table, and that's what you get, 0.5359, which is what I got when I did 1 minus this. You get? Okay, so what's the answer now? 0 points. How did you calculate that? That was this minus 0.3264. Okay.
So confirm now that I can solve the other way, and if you don't answer,
So what's the probability? Another question, simple one. What's the probability that in any given year would have a return that is greater than 27%? That is greater than 27%.
minus 0.5.
No, that's like,
Yeah, 1 minus 0.5 to be the answer.
1 minus
0.5 Z value of the mean, which is
that is greater than 27%.
I think it's
that was
that 1 minus 0.559.
Yeah.
Yeah.
Is it clear?
It's greater.
So I said, what's the probability that returns will be greater than 27, which is represented by this portion? So you already know your probability. So you just subtract 1, and that probability is representing all the way to this point.
Well, you have the positive table, you don't need to subtract.
If you have a positive table, it depends.
Okay.
So if you have a positive table, you check Z is equal to 0.0909. What you would get would represent this portion all the way to this point. What you are looking for is from this point down. So you should subtract. You subtract from 1.
So you subtract 1 from that 0.5 then.
You subtract 1 from this, yeah.
This is equal to this, like this side is equal to
This tail, yeah.
So when we wanted to find this one, I've gone to say so rather from 1 times to go for the other parts.
Okay, when we did Z is equal to minus 0.09, we got
Got down 1 and we subtracted 1. It's from 1.
to get this entire, yes. Shoot.
I like the voice.
Yes, now. Is it my board?
So this last question.
Yeah.
We got I don't know, it might be a funny question. This last question we did.
Yeah.
15. And then to get on this other side, we minus to get here.
Okay. To get for which other side now?
To get for this one, we minus.
Okay, I understand your question. So we solved for 15. When we check our table, it's represented by this portion I've shaded. Then we checked for 27.
Yes.
When we check our table, it's represented by this entire portion all the way
So
down.
we're still minusing 1.
So why are we still minusing 1?
This question, this table is already giving us down here.
I said what's the probability that it will be greater than 27?
Greater.
Greater is from this point down. So what you checked on your table is probability that it will be less than.
No, my question is for this 15 and 27. Between
Okay, between.
15 and 7.
So between 15 and 27 is between year and year.
Yes.
So 27, what you calculated as the probability is all the way down. For 15, what you calculated is from this point all the way down. So if you subtract them, you'll be left with between 15 and 27.
Question is, for this 15, did we subtract anyone?
For the 15,
This 0.45.
okay, minus 0.45. No, we didn't.
This one, we are subtracting from 1.
Oh, she's talking about the table.
About the table.
Table. You know, we are using
Okay. And because we are using a negative table,
What is
and our Z,
down here?
our Z here is positive. So if we use a negative table, the value we are checking is minus 0.09, which will be from this point all the way down.
My understanding is this. I'm so sorry.
Yeah.
I mean, stop laughing. My understanding is this: the negative tables, they check this way. Positive tables, they check this way. So if our negative table is already helping us to check this way,
Yeah.
why are we still minusing to get this way? Am I asking my question already?
No, I'm not sure.
Negative table is
Okay.
giving us from here down. This 20
Yeah.
giving us from here down. That means this one is 0.46 giving us from here down because this 15 gave us from here down. Negative.
What Z value did you check from this point?
This what is 27 minus 25? 2 divided by 22.
Okay, you checked 0.0909,
Yes.
but from a negative table. Yeah, continue.
Giving us here downwards.
Yeah.
And you're saying we should still make -1 from here.
Mm-hmm.
But this negative table gives us all this way. It always goes left.
I still don't get your question.
We don't know it. No, in between
I
is
get what-
different. In between is when you're nesting here from here.
Mm-hmm.
We're talking about this 27 here.
Okay, when I said what's the probability that it will be greater than 27? What? I'm not.
Saying that after we have gotten the value from the table,
Okay.
subtracting from 1.
It depends on what we are calculating.
We're calculating down here. And it's already giving us down here.
Say it in words. What is it? Are we calculating between 15 and 27?
She's talking about the table.
21 is positive.
Well, the answer we want is the positive answer. Now you can, yeah, it's positive, no negative. But we only have a negative. We don't have a negative.
So the thinking is about negative and positive. But it's not negative.
I still don't get. Okay, you say 0 is not negative, Abby. This table is a negative table. So it's because it doesn't make sense to put minus 0.00.
I had a problem with that.
Okay.
We're looking for something that's giving us here.
Yeah.
Negative tables give us
But the
down
answer
here.
is a positive.
Mm-hmm.
But the answer is positive. So that makes sense. Yes.
Yeah, it will be there. So we use negative there with substitute. Yeah.
The question. Look at how much today.
I don't.
For the answer, like
That's for greater than 27%.
Talking about the answer.
Okay, for 27. Okay, continue.
if you get your answer, you say, okay, say you're looking for 15 minus 15. Like if you're looking for 0 minus 0, like
15 is
Okay, yeah.
that gives you the value of that, like in 15 downwards, like the shaded part of the wall.
Okay.
It's positive to they give you the answer downward, or it gives you the answer upward.
Okay, I think I understand what she's saying now. So what you're saying is, if the table is a positive table, that what you are checking is from that point to the right. Okay, I get what you're saying.
more than.
I get what you're saying. But at the end of the day, it will still boil down to what exactly am I calculating? You understand? If what I'm calculating is between 15 and 27, and I checked a positive table that gave me probabilities of from this point all the way down. So for me to get between 15 and 27, that means I need to check what 27 is all the way down here. Sorry, what 27 is all the way down here and then subtract.
The 27 that we checked, so I think it's 27 and after this, 27 to this side.
Yeah.
Yes. This is 15, right? We keep on increasing negatively.
So
So
that's 27 is positive, it's not negative.
you don't get my question. We are actually negative table. So 27 takes 27 as after this face to the left.
I don't believe you.
Oh, yeah, wait, let's go back. Let's go back. When we use 27, what is our z value? When we use 27 as our x, what was our z? 27 minus 25 over 22, right? That's 0.0909, right? Which table do I have in front of me? Negative. So how do I check the negative table? Which is what? This 0.4641. So that will give me my probability from here, where?
No, I don't. That will be your probability from after 15. Put 27 after 15.
Up one, that would be wrong.
27 will be this way. 27 will be this way.
Probability if you like change the bell shape to the one that's like.
No, this is I want to understand something. This is the negative table, right?
Yeah.
So we're assuming that the 27 that we are checking is negative, right? No.
Uh-uh.
I'm sorry. I'm going to be
But if you have the positive,
It's the same answer.
More often than not, you would find yourself with one table. It's either a negative table or a positive table.
so this
It's very rare for you to have the two tables. If you have the two tables and you've calculated your z as 0.09, go to the 0.09 positive table, check the value.
This therefore
You understand?
forward. Can you draw a new table and shade where it is?
This 0 points.
Therefore forward. Can you draw a new table?
Not 0.9.
See, if you draw a new table
No. Just draw
I
a
still
new
don't-
table and indicate where it is.
before 15, before
25.
before 25, after.
Can you shade where this 0.464 is? Can you explain where is it? Where is it facing? This 0.464.
Okay. It's facing this way. Yes. It's facing this way. But remember that to get what we use as our probability of 27, we subtracted 1 from this. So what we actually use is this portion. Do you get?
And that question, this is my final question. I don't stop you here. Please shade a new table, draw a new table, and help me put where 0.45 is.
Where minus 0.45 is. Okay. And that's where it is now.
And we're trying to find here.
We're trying to find
This side.
After the
from,
So
we're trying to find this portion. Assuming this is our 27 now.
yeah.
So this is what we're trying to find. How do you find it?
wait now, dear, calm down. I'm fine. My question is answered. My question is answered because originally I thought that this thing faces this way because all the questions we've been doing under negative and facing the negative.
Okay.
So we are saying that all these ones here we face this side. Is that what you're saying?
Yes.
And then
But because what we are trying to solve for is we're trying to solve for this region from this point to this point, right? And to subtract it, the first time you calculated, you have this portion, right? But you know that this portion, you can find the symmetrical value at this other side. That's why when you calculated this probability, you subtracted 1 to get this entire from here all the way down.
I understand.
Then for the other one, which is pretty straightforward, you got this portion all the way down. So you just do your subtraction.
So finally, if the question is to come out, I'm to understand that 0.01, that straight line is the right, facing the right. And then all the minus is facing the left.
Well, if it won't confuse you, you can understand it that way. But there's a risk. If you understand it that way, then you must make sure that you draw the table. Otherwise, you mess everything up. Do you get? Remember I said, know exactly what is the question asking for. Which area am I looking for? Once you know the area you are looking for, then you now need to, you can now tell, okay, how do I make out that area from the information that I have?
I think it's just well, if you remember just probability or I don't know. I you guys remember probability. Okay, don't worry.
So 1 minus now.
That 1 minus
1 minus, like the complement. Yeah.
So since you have a particular value to the set, but it's negative, so the inverse of it will be positive. So 1 minus the z and negative value will give you the answer.
So the carry away is when we have the positive and the negative value
We are looking for.
minus. The other way,
Yeah.
What if you have a better positive statement? Like, what do you say? Like, just
If you have a positive table, now it depends on what exactly are you trying to calculate. And how do you get that area out from the information that you have? So if you have a positive table, right, and like she's arguing, you shade to this way. Now, if the question says, calculate this region, you understand, and you've checked this value on your Z table, is a positive value. This other value is a positive value. So for this other side, it will be this way shaded all the way down. And this one will be shaded all the way down. So you can see that it's just this minus this. Do you understand? So first thing first is know what probabilities you are calculating. Like, what am I looking for? If you know what you are looking for, know what am I checking on the table. If you know what you are checking on the table, you can figure out how to calculate what you are looking for.
Yeah.
I'm starting. Perfect. So,
No, it's not. You are not disturbing. Honestly, you say you are disturbing. No, you're not disturbing. You're not disturbing. What you're saying would work perfectly well where the two z values you are comparing are positive and you're checking a positive table. You get, if the z value, one of the z value is negative and the other one is positive, then you face this problem of how do I make it symmetrical on one side so that I know what I'm taking out? I don't even know if you understand what I'm saying.
So just
Let's solve another problem. Okay, I'll give you two problems. No, I'll give the class two problems and I want you to solve it in that way that you understand it. The two of them. Now I would give you one where what we are looking for is to the right of the mean. That means our z values will be positive. You understand? The first z value, imagine it was between 27 and 29. Your z value here will be positive. This other z value will be positive. Then you can easily do that when I check my positive z table is to this portion and the other one is to this portion, so I can subtract to find the range. Then I'll give you another question where there is one that is your z value will be positive and the other one will be negative. And I want you to do it that same way. You get? Okay, so find between 23 and 27. That's the A part. Then the B part is find probability of between 26 and 28. See, probability questions, usually you can solve the question using multiple ways and you arrive at your answer. Yeah. Like find the probability that in a given year returns will be between, the first one is between 23 and 27. Then the second one is probability that it will be between 26 and 28.
Is it the same mean also?
Yes, with the same mean and standard deviation. When you are checking your table, be sure you know what exactly you are checking. Am I checking probability of x less than or equal to z? Or am I doing the reverse? A pin board. This portion or everything? Okay. Hope we've written down the question. That's all. So the first one was 23 and 27, have you?
That's your phone.
26 and 28. Okay. Mean 25. 22, have you?
Yes.
Okay. What solved A? 0 points. 1.
718.
That's the final answer, right? How about the second one? Final answer? What's the answer? 0 points. For the second one, 0 points. What did you get? What did you get? What did you get now? What? Let me see. 0357. Okay. You want to come and explain how you got your answer? Okay. You want to explain? Yeah. You're the one that gave me this one, have you?
I don't need to stand on it now. Can't I just say?
Okay, say it.
Okay, so because it was a negative thing, what I did was when I got the 0.26, it gave me 0.0.
How did 0.2? Sorry, how did you get 0.26?
Minus 25 divided by 22.
Okay.
So that gave me a positive 0.045. So I should write.
Our mean, we are looking at B. Everybody got the same thing for A. Okay, so for B, our mean was 25. But then we are looking for between 26 and 28. So let me say this is the 26. And this other point is 28. So we want to calculate the Z values. You said you got the Z value for this one as what?
0.045.
The other one, Nko?
0.136.
0.1364. Okay. So how did you now get your final answer?
Because it was positive addition. So we should do like this. So I now did 1 minus 0.045 and 1 minus 0.1.
Okay, so you checked for minus 0.045. You checked Z of minus 0.0.
I didn't even check because I did not see this.
Okay. Okay, do you want to continue?
I did mine in 2 ways.
Okay.
The first thing I did was, sorry, excuse me, class, 0.04
It's 55.
Yeah.
Sorry, I'm on the wrong one.
0.05.
But then it's in between.
0.05.
Is in between these two numbers, Abi?
What we did for was taking the other one because the last one we did for, I was asking you.
And continue. Continue.
So I and then the other one is
If you want to do pinpoint accuracy, you look for the
me.
like the difference between the two. You know the way you do you prorate, yeah.
So that is this.
But let's use this one, yeah, because it's midpoint. Yeah.
So this is the next one, 0.1. Okay, can you that was like right?
This.
That's 0.13.
It's only this all we can get now.
Okay, 0.13. Okay, so you use this. Okay. Although I could have rounded up, but
So what I did was I did it in 2 ways.
Okay.
What he said. I mean, don't beat me up now. Sorry.
well, you can't beat it now.
You can't beat me up. And I took this at the first glance because I was saying if I'm taking this, that means both of them are going this way.
So what you checked was minus 0.04
Yes.
for the first one, Abi.
Yes.
If you checked it, what you checked on the table was actually minus 0.04, which would have given you this.
So what I did was I did the minus on them. These two, I just put them here. I'm not saying it well.
And continue. So you have minus 0.04 and minus 0.1.
Let me just say what I did. The first one I did was I left both of them.
By 1.
No, I just left both of them. And then the second one I did was -1, then less them. Because both of them are still going to be the same. Because both of them are still going to be in the same thing here, symmetrical. They are not crossing the.
I get what she's saying. I get what she's saying. That's the way a pro would solve it. No, I'm serious. Well, what happens when they're in? It's the same answer you'd get. 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 So if we're looking at it the way I've been explaining it, so because what you check is minus 0.045, because unfortunately you have a negative table. So that would be what? Minus 0.0, that's 0.4840, which would give you this portion. So I'll minus 1 to get from this place to this place. So I would have shaded this point like this for that my probability. Then I'll do the other one, minus 0.13, minus 0.14. But you use 13. Let's just use 13. You'd have gotten 0.4483, which would have been from minus 0.13, which would have been from this point downward, right? So to get the symmetrical part from this point down, I'll do 1 minus this, right? So that would give me, what did you get? That would be 1 minus 0.448 whatever. So that will give me from this point all the way down. So at the end of the day, it's not be the answer I got here minus the answer I got here. That will give me what is here. You still get the same answer.
Why is long?
Yeah, I also want to. I'm interested in getting what if I want to get the exact value of 0.045.
If you want to get the exact value, so you have 0.04, and then you have. So what you are looking for is 0.045, right? This one, is giving us 0.484. While this one, if you check the table, you are getting 4801. So what you just need to do is to prorate. Actually, I don't need to prorate because it's exactly midway through. So I'll just sum this and divide by 2. And that will give me what my z.
It's less than 0.47.
If it's 0.4, sorry, let's say this is 0.047, which is somewhere here. So I'll just check what's the difference between 0.04 and 0.05. That's 0.1, right? What's the difference between here? Like what portion of the way is this guy? So you just get the percentage of that and you add it to 0.484. You get. Hope you understand what I'm saying.
I just wonder why you know things like something small. Like, I don't understand this one. Say, you say, the open so it's over. I don't say so.
You do when you checked, you have a negative table, right? But your z that you calculated is a positive number, right? So you are forced to check the negative equivalent of that number, right? So you can check minus 0.13 and you check minus 0.04. You can subtract them straight up to get the region in between. That's what she did, and that's the smartest way to go about it. Yeah.
0.4 maybe and 0.4 around there.
You understand? That's if you check the positive table, you would have shaded this part like this and this other part. So you would have just done the subtraction straight up. But because you are checking the negative table, to check minus 0.045, the figure you get, you subtract 1, like 1 minus that figure, will tell you what the, like this portion, what's the probability of this thing coming out would be. You check for this other part, it will give you what the probability is from this point all the way down. So you just know is to subtract this probability minus this one to give you this area. You don't understand. See, when you start then, if we had a positive table, see, if we had a positive table, our problem would have been sorted because we'll just check the probability of this one, we'll straight up, we'll get the answer. Probability of this one straight up and we'll subtract. That's all. But because, unfortunately for us, we have a negative table and our z that we've calculated is a positive number. So we now have to check the z table for that negative number, subtract that probability from 1. Do you understand? So to get 0.045, when you're checking on a negative table, you are checking minus 0.045. If the probability you get there is 0.1, that means for 0.45 is 0.9, which is 1 minus. Do you get? You're just shaking your head. No, she's not getting it. Yes, please.
What you saw it yes was it not less.
Which table did you use? This is our table. Okay. So you check this figure, Abby. You got 0.484. So that 0.484 is for which portion on this our curve? So what she said is that if you are checking this our table, this negative table, remember what you have here is what you are checking is probability of z less than or equal to x when you are checking the negative table. And probability of z less than or equal to x is, if this is x, is from this point all the way down. If you check the positive table, who has the positive table? This one, okay. So if you have a positive table, so what you will be checking, assuming we had a direct positive table for 0.045, I'll just come here to check 0.045. Of course, we'll do the midway if we want to be accurate. That will give us 0.5160 for the 0.4. When we check this one, what did we get? 0.04. We got 0.484. If you do 1 minus this, it should give you this 0.516. You get. So what we have tried to do by using this negative table is to try to figure out the positive value.
Now, okay, now that we've got the positive value, what we now do? Well, after that, we now add them together or subtract them.
You subtract. Okay, I didn't get you now. Sorry, I didn't get you. You subtract. Okay, if you want to prorate, like if you want to get the exact figure for Z, for 0.04, this is the figure, 0.484, the probability. For 0.05, it's 0.48, right? So if you want to get for 0.045,
Let's say it's like 0.047.
if it's 0.047, what's the difference between 0.05 and 0.04? 0.1. That's the difference. So 0.07, which is what you are adding to 0.4, is how many percent of the way? It's 70% of the way. So that will be 70% of the difference is what you add to this guy.
Oh, I get it.
You get? Yeah, is what you add to the lower bound.
0.01. No, 0.1.
Which one? And the difference is 0.01. Okay, I'm just saying 70% of 0.01. That will be 0.0. Okay, so I said this is 0.04 minus, okay, let me just use a number line. We have 0.04 here, 0.05. We're trying to find the figure that is here. That's 0.047. So how do you do this? It will be, you know this 0.04, there's an answer for it, which is what? 0.484. This 0.05, it's 0.4801. What's the difference between these two figures? That's what this minus, which one is bigger? This minus this. 484 minus 4801. 0.0039. So 0.0039 is the difference. So we're now trying to say if this guy is 70% of the way, how did I get the 70%? This minus this divided by this minus this. This minus this is 0.007 divided by 0.01, right? This would give you, now multiply this, whatever it is, by the difference, which is this. So by the time you do the multiplication, it will now give you what you will add to this guy.
So yeah,
To get, what would this figure be at this point?
different, which we have based on the 0.04.
For a,
Yeah.
okay, in this case, it will be subtracted.
Yeah, it's
It will be subtracted because it's reducing.
0.07.
This figure is greater than this one. Which one?
Yeah.
484.
No, he's looking at the actual one, not the one you wrote. The actual one is actually going up, but the one you wrote is going down.
Okay. People are confused. 0.04. Shebo only. This is now 0.48. This one is 4801. In fact, that means the difference that we calculated is what? This minus this is supposed to be a negative figure. It's supposed to be a negative figure. So you still do that, this divided by this times this negative figure. Oh my friend, negative. Add that negative to this guy.
So that formula is not there.
Minus. What you are doing is you are taking away that figure from that 0.4874. What you are just doing is you are trying to see if. How will I explain it?
Negative formula of L times B.
Exactly, that we have x2 minus x1 over b minus a. It's just something like that. Do we get?
Yeah, we do get it.
Let's
This thing can.
keep it looking.
But most likely, if what you have is maybe, if you don't have a problematic situation like this 0.045, just round it up and check the nearest z value. In CFA, when they ask you the question, they say the probability is maybe most nearest to or whatever, to account for all this. Yeah.
Round is 4.
Okay. Shoot.
It's about this thing that we are calculating.
Okay.
Stay up. So we left it. Fine. We left it.
Okay. Can ask me after. No, once when I do.
I don't want to game.
I'm sure we can attempt all these examples.
Yeah.
Let's keep this. Okay, let's look at this question. We're not going to solve it, but I just want us to think through it. It said a study of hedge fund investors found that their annual household incomes are normally distributed with 175,000 and the standard deviation of 25,000. So the question is, what's the percentage of hedge fund investors that have incomes less than 100,000? So you calculate the z value, right? Once you calculate the z value and you check for it, you know that what you are checking for is from that z value down to your left. Do you understand? Yeah. It will be a different question if they said, what's the percentage of hedge fund investors that have incomes greater than 100,000? In that wise, what you'll be calculating is from that z value of 100,000 to your right. Do we get? No. Okay, let's do it.
Don't say it again. Just take it.
What's our mean? I should clean the board. Our mean is 175,000, right? Mean is 175,000. Our standard deviation is 25,000. Our x, based on this first question, is what? 100,000.
Okay, that's it.
So you calculate your z. X minus mean over standard deviation. Minus 3. So you go to your table. Thank God we have a negative table here. So we just check it straight up. So minus 3.
Minus 3, 0. No,
Is minus 3.
Okay, not 0.3. Go. 0.0.
0.00013.
0.0.
13. Okay, it's 13.
Okay,
13. It's straightforward because what we are calculating is probability that is less down. If we were calculating probability that is greater than, it should have been 1 minus this, it would have been the larger part of the distribution. Do we get? Okay, so this next one says percentage of hedge fund investors that have incomes greater than 225. Our X will be 225,000. Calculate our Z value. Then you take that Z value, you check your table. Remember, what you are trying to find is greater than whatever Z value you calculate. That's to your right. Okay, so let's do that. What's our Z? 225 minus 100,000. That's 125 divided by 25.
75.
Sorry, minus 175. That's 50. That's 2. I hope I'm correct. Z is 2, Abby. So you check the Z table. For Z is equal to 2. Now what we have here is negative 2. Right? So if I check Z of minus 2, that's what? 0.0228. Which would be, our Z was 2, Abby. So what we check from the negative table is Z minus 2, which is this portion. So to get the remaining of this portion, okay, what are we calculating? Is it greater than? Greater than. So this is synonymous to this portion that we're trying to calculate. That would be my answer. Do we get? What we checked on the table